Have you ever gazed up at the night sky and wondered, how did all this come into existence? As you stand beneath the vast cosmic blanket, this question might seem almost as immense as the universe itself. But don't worry, you're not alone in this cosmic curiosity. For centuries, humans have been probing the mysteries of the universe. Today, we're going to delve into one of the most widely accepted explanations for the origin of everything we see and don't see. Well, the answer might lie in what scientists call the Big Bang Theory. The Big Bang Theory, despite its complex nature, can be broken down into simpler, more digestible parts. Let's start with the initial singularity. Picture this, a point of infinite density and temperature, seemingly small and insignificant, but it contains all the matter and energy that would eventually become our universe. This is the singularity, the starting point of the Big Bang. Now, imagine this singularity exploding. But hold on, this is not your typical explosion. It's not an explosion in space, but rather an explosion of space. That's right, space itself was being created as this singularity expanded. This is a critical point to understand. The Big Bang didn't happen somewhere in space, it was space. Following this explosion came the expansion. Imagine a balloon being blown up. As the balloon expands, every point on its surface moves away from every other point. Similarly, in our universe, galaxies are not flying away from a central point, but space itself is expanding, causing galaxies to move away from each other. This expansion didn't stop. In fact, it's still happening right now. Over billions of years, this continuous expansion has led to the universe we know today, filled with galaxies, stars, and planets. So, in essence, the Big Bang Theory proposes that the universe started from a singularity and has been expanding ever since. Now that we understand the basics, let's dive deeper into the key points that make up the Big Bang Theory. One of the most compelling pieces of evidence for the Big Bang Theory is the detection of cosmic microwave background radiation, or CMBR for short. This is a faint glow of heat, almost but not quite uniform, that permeates the universe in all directions. It's the afterglow of the Big Bang, a snapshot of the universe when it was just about 380,000 years old. Remarkably, this discovery was made quite by accident by two radio astronomers, Arno Penzias and Robert Wilson, back in the mid-20th century. The next key point is the abundance of light elements. You see, the Big Bang Theory predicts that in the early stages of the universe, conditions were just right for the formation of certain elements: hydrogen, helium, and traces of lithium. As the universe cooled, these elements became locked in, forming the first atoms. The proportions of these elements we find in the universe today match the predictions of the Big Bang Theory remarkably well. Then we have the redshift of galaxies. This is a phenomenon where light from distant galaxies appears redder than it should. A bit like the way a siren sounds different as it moves towards or away from you. This redshift happens because the universe is expanding, stretching the light waves along with it. Edwin Hubble was the first to observe this, leading to the realization that the universe is not static but expanding. Lastly, there's the cosmological principle. This is the idea that the universe, when viewed on a large enough scale, looks the same no matter where you are. This uniformity, this sameness, is what you'd expect from an explosion of the magnitude of the Big Bang, which should scatter matter and energy evenly throughout space. These key points provide substantial evidence supporting the Big Bang Theory. The Big Bang Theory doesn't just explain the origin of the universe, it also provides a framework for understanding its future. Diving into this future, the Big Bang Theory presents us with several intriguing scenarios. One is the Big Freeze, which paints a picture of a universe gradually cooling down as it continues to expand. Over trillions of years, stars would burn out, galaxies would drift apart, and eventually, even the energy of black holes would dissipate, leaving a cold, dark universe. Alternatively, there's the Big Rip. This scenario proposes that the universe's expansion isn't just continuing, but accelerating. If this acceleration is relentless, then in the distant future, the fabric of space-time could be stretched to its limits. Everything from galaxies and stars to atoms themselves could be torn apart. Then we have the Big Crunch. This is the exact opposite of the Big Bang. Instead of expanding, the universe would start contracting. Gravity would pull everything back together into a singular point, possibly restarting the cycle with another Big Bang. But these are just theories. The truth is, we're still trying to understand the dark side of the universe. Dark matter and dark energy, two mysterious and unseen forces, make up about 95% of the universe. These dark entities could be the key to understanding the universe's destiny. Dark matter, although invisible, exerts gravitational pull, while dark energy seems to be driving the universe's accelerated expansion. We don't yet fully understand these cosmic phenomena, but with each scientific breakthrough, we're getting closer to solving these cosmic mysteries. The Big Bang Theory, despite its name, is not just about the birth of the universe. It's a narrative that spans billions of years, from the universe's fiery inception to its uncertain but fascinating future. So, from a single point to an ever-expanding cosmos, the Big Bang Theory provides a fascinating explanation for the universe we see today. So, there you have it, the Big Bang Theory, a scientific attempt to answer one of humanity's oldest questions. In the blink of 7 minutes, we've journeyed back in time to the very beginning of our universe. We've tackled the concept of the Big Bang, simplified it, and highlighted its key components. We've delved into the singularity, the explosion, and the subsequent expansion that birthed galaxies, stars, and all forms of matter. We've also pondered the mysteries that lie beyond the Big Bang and how this theory continues to shape our understanding of the cosmos. Through this journey, we've seen how science continually strives to make sense of the infinite, to decode the cosmic puzzle that is our universe. It's a testament to human curiosity and our relentless quest for knowledge. Next time you look up at the stars, remember, you're seeing the aftermath of a cosmic event that happened 13.8 billion years ago. The universe might be a big place, but thanks to the Big Bang Theory, it's a little less mysterious.